At 9 first. So the equation is y equals x squared. They give me this point x equals -2. I'm going to go ahead since I'm here and say if x is -2, what is y? 4. I'm going to need that several places within the equation. Now I'm just going to take that difference quotient, right? And I'm going to find the slope because the difference quotient is going to give me the slope of the tan line at the point x equals -2. Okay? So the limit as h goes to 0 of, remember it's f of x plus h minus f of x over h. And my x is -2. Yes? All right, so I've got the limit as I go to 0 of, well, what is f of -2 plus h? I'm taking this and it's going in for the x, right? So -2 plus h squared minus, I know f of -2 is 4 over h. I feel like we did this one. I remember the 4. Okay. Okay. So I got the limit as h goes to 0. If I FOIL this out, I would end up with +4 minus 4h plus h squared. The 4's cancel. And I have the limit as h approaches 0 of, I'm going to write it this way. So I can factor that h out. An h and h and h. So now I have the limit as h goes to 0 of h minus 4. That's it. Put in 0 and I get -4. So the slope of the tan line at x equals -2 is -4. And I know that that point I had, remember, was -2, 4. So now I just plug in point slope form. Y minus 4 equals slope times x minus x1. And of course, you can go through and solve that for y. Just throw that 4 to the other side. It's that difference quotient formula. That's the hardest thing to me to remember. Let's do 12. Ooh. Oh, wait. 10? Okay, 10. Yep. Yeah. Right. For this one, so if I did f of x plus h here, is that what you're asking me? What would this be? It would be x plus h squared minus 4x plus h. Everywhere there's an x, I'm replacing it with x plus h. And if I wanted to go ahead and FOIL this out, x squared plus, together and doubled, 2xh plus h squared minus 4x minus 4h. This is number 10. So she was saying she set hers up. Remember yesterday how some of them I was coming off to the side and I was doing f of x plus h and I was doing f of x and f of whatever. So if you do it off to the side, I haven't plugged in yet. I don't think this doesn't really clean up any. That's it. If I think about it being, okay, if I plug in 1, I get 1 minus 4, which is -3. So let's plug in that difference code, because I'm looking for the slope of the tan line when x equals 1. So that's going to be the limit. What? Yes. 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 That's exactly right. You should. Mm-hmm. You.
Oh wait, no. In our little made-up formula that was just
Because remember, your formula is f of x plus h minus f of x over h. Okay. So what I'm doing is I'm plugging in, if it's f of x plus h, I take, this is really f of x, right? F of x and y is the same thing. Everywhere there was an x, I'm going to replace it with x plus h. And for this one, it's already f of x. But I'm finding specific values here, which is why. Yes. And we're doing it at values right now. Pretty soon we'll be able to do it for an equation, a general equation. It'll be such fun. Okay. So let's plug in what we know here. It's getting hot in here. The limit as h goes to 0. I've already done f of x plus h. I did all that on the side. Y'all okay there? And actually, what I need to do is this, right? So I need f of 1 plus h instead of f of x plus h, right? Because I'm looking at that specific point. So here, I've already done all this math work, so I'm just going to plug in here, I'm going to plug a 1 for every x. Are y'all following with me, or do I need to go back to the beginning? Okay. So 1 squared plus 2h plus h squared minus 4 minus 4h. I just threw a 1 in there for every x, which would give me, that's negative 3, 2h plus h squared minus 4h. Oh, okay. All right. Oh, I was supposed to. I see what you're saying. Y'all okay there? Whether you did it here or whether you just went straight in and didn't put, you put 1 here and 1 here. Right? Either way, this is what you should come back to. Are y'all with me? And then here, so this is 1 plus h. I also need f of 1. F of 1 I already did in the beginning. It's negative 3, right? Okay, so now I have negative 3 minus 2h plus h squared minus, what's f of 1? Negative 3 over h. Well, look what happens. Dun, 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 the same thing that always happens. You should be starting to see a pattern here as we do this. They should be, yes, so that you can cancel an h out. Yes, yes. Right now, yes. If it doesn't, something's going wrong right now. No, that's, the shortcut is so much shorter. You're going to be so mad when you see the shortcut. So now I have the limit as h goes to 0 of negative 2h plus h squared over h. And now I can take an h out of everybody, right? What is it? Negative 2. What have I found? What is that I found? The slope of the tan line when x equals 1. Because remember, the slope of the tan line is going to be different depending on where you are. As I make my way around that curve, it's different. So when x is 1, the slope of the tan line is negative 2. I need a point and a slope to write the equation of a tan line. I've got a slope. What point am I going to use? The point of tangency, right? What is it? 1. So now I just write the equation. 1 plus 3 equals negative 2. Yes, no, maybe so. It takes us, we will practice with this so much, I promise. Oh no, that's next unit. I know, it's like right. But this is the last section in the unit. 12. I'm sure I'm not supposed to show you. 12. Oh, gross. X squared minus 3x minus 1 at x equals 0. All right. The slope of the tan line when x equals 0 is the limit as h goes to 0, f of x plus h minus f of x over h. But I am going to evaluate this when x is 0. Y'all okay there? This makes it a little bit easier because really this is just h goes to 0, f of h minus f of 0 over h, right? Because 0 plus h is just h. Well, that is, just put an h everywhere there's an x. H squared minus 3h. Now plug in a 0. What's f of 0? Negative 1. Did this one not work? Should have. Oh, I didn't do the minus 1 here. That's why. And now I do minus negative 1. That's right. That's right. I got you. These are gone, right? Boom, boom, boom. What's the slope? Remember, f of 0 we said was negative 1, so I got y plus 1 equals slope. Don't lose sight of what it is that I have found, right? This is the equation of the tan line. So whatever else this curve, is this a quadratic? Quadratic going up, something, whatever. Whatever it is, here's my quadratic, right? I've got this point of tangency, so we'll say that this point is 0, negative 1. The line that goes through here, the slope of that line, nope. Y'all see why I knew I was wrong on the wrong side? Slope of that line is negative 3. It was positive on the other side. Slope of this line is negative 3. The equation of this line, only that line that goes through that very one point, is negative 3x minus 1. If I move that line anywhere, if I move that point of tangency here, that is a different equation of a different line. It's a different point of tangency, it's a different slope, it's a different line altogether. So this is unique only at that one point. Isn't that cool? So you could think about it as if you factored an h out of here, out of the whole thing up top. So now if you have something in the top and the bottom, remember once we get all the pluses or minuses enclosed in parentheses, we can cancel out. Yeah. As long as you take it away from everybody, you can do that. Are you feeling a little bit better? A smidge? All right, I'll give you a second to get your homework turned in and stuff before we switch gears and do. Y'all think Robert's going to watch this? Hey, Robert! More tan lines. Mike's mad at you, Robert, for not coming to the game. The game? The game. The game. All right, so Been doing a lot with tan lines, yes. We're still doing more tan lines, but we're gonna add a little something to it. What do you mean? Like we use algebra to do the calculus. The tan line stuff is all calculus. Like that's you don't do tan lines anywhere else. But as far as the manipulation, that's algebra. I know y'all hate trig. That might be my fault because it's not my favorite, and so I feel like I have kind of like put that off on y'all. I was like, memorize the unit circle.
Yeah.
Okay. Okay, some more tan lines. Let me think what I need to tell you more about tan lines so we can do these problems. We talked in the beginning, remember we were doing average rate of change? AROC, and we said that that is just slope, right? Slope on an interval or between 2 points. Well, now we've still been talking about slope, but we've been talking about slope at one specific point, right? And that's the slope of the tan line. So this slope of the tan line, and I've kind of mentioned this before, but this will be a little better terminology that we'll use from here on out. So slope at just 1 point which is the tan line slope, is the instantaneous rate of change. And guess what we call that? IROC. So a lot of the questions that you will have, you will determine whether you need AROC or IROC. And so if we're looking at change at a specific point in time, we're talking about IROC. And if we're talking about change over a period of time, we're talking about AROC. Does that make sense to you? Spanning versus. Always go back to thinking about that graph in the beginning where we're trying to get that H smaller and smaller and smaller so that we're instantaneous rate of change. Are y'all okay there? All right, so we talked about the slope of the tan line being IROC. We also have something called a normal line. Have you guys heard of a normal line in geometry before? All right, so the tan line intersects at just 1 point, right? A normal line intersects the graph at 90 degrees. Why is that, or actually intersects the graph, I should say intersects, I'm gonna put it this way, intersects the tan line through the graph, sorry if y'all already read that, at 90 degrees. So if I've got this, let's say I've got this parabola, here's my tan line, right? I've gone through that difference quotient, I found IROC, I found the slope, I've got the equation of my tan line. I can use that information to also find the equation of the normal line. The normal line is going to go through that same point of tangency, but the difference is instead of skirting through at 1 point like that, it's going to be perpendicular like this. Perpendicular to the tan line. Which tells me what about slopes? Now you got to go back to algebra. So that's exactly right. The slope of the normal line is the, let's say it's negative reciprocal of the slope of the tan line. Does that make sense? The normal line is perpendicular to the tangent line. Do you see why the normal line couldn't be a tangent line? It keeps going, and what happens if it keeps going? It intersects again, so it's really what kind of line? A secant line, that's exactly right, a red line. It's a secant line, right? So a tangent line hits just at 1 point, there are lines that go on forever, but that purple line would keep going because it is a line, and it would hit twice, which would actually make it a tangent line, not a secant line. Okay. The normal is perpendicular to the tangent. The slope of the normal is the negative reciprocal of the slope of the tangent. So maybe write that out in your notes because that's my shorthand. The slope of the normal line is the negative reciprocal of the slope of the tangent line. Yep. The slope of the normal is the negative reciprocal of the slope of the tangent. What? Oh. All right, y'all ready to do one? Sure. Thanks, ready. Let's say f of x equals 4 minus x squared. Find the equation of the normal line at x equals 1. Mark, set, go. The slope of the normal line should be 1/2. The slope of the tan line is -2. Then change the sign and flip it to get the. Let's do it together and see what happens. Don't do that! Okay. All right, let's do the slope. Let's do the slope of the tan line when x equals 1 first. Then we'll do the opposite reciprocal to get the normal. All right, so we'll do the limit as h goes to 0 of f 1 plus h minus f of 1 over h. It says when x, did I tell you -1? Oh, no, okay. That's why I got confused. Okay, that makes sense. Okay, so now I'm going to plug in. So f of 1 plus h is going to be 4 minus 1 plus h squared. Yes? We're just replacing this x with 1 plus h. It never works. I bet it's a negative sign that you messed up on, and I'll show you where I bet it is. Minus 3 over h. F of 1. Okay, tell me where I lost you. That's okay. That's all right. Yes. Well, this is, remember, order of operations. So exponents come first, then subtraction. So square this x first, and then do 4 minus whatever the square of that number is. Then it'd have to do minus 4 plus 1. Because if you put the minus here, and then if you did minus f of 1, that's right, you'd have to do this. The f of 1 altogether is 4 minus 1 squared, right? If you just do minus 4 minus 1, then what you've done is only subtracted the 4. You've not subtracted the -1 also. So it might be easier, come off to the side, find this value off to the side, and then plug in just that value, what you get. So you don't mess up on signs or anything like that. Do the same on this one. If you want to come over to the side and say, okay, f of 1 plus h is, and find it, and then come down and plug it in, it might be easier. So this would be, like if I did that here, I'd get 4 minus 1 plus h squared, which is 4 minus, and I'm just going to work inside this little FOIL part of this problem first. 1 plus, together and doubled is 2h plus h squared. Okay. Now that minus has to distribute through, right? Because I'm subtracting that whole function. So it's 4 minus 1 minus 2h minus h squared, which is 3 minus 2h minus h squared. It's that negative distributing. It's always something silly like that. Now that brings me here. 3's are gone. Negative 2h minus h squared over h. Take out an h. Oh. When I came over here and did f of 1 plus h, this minus has to go through to everything. So now I have negative 2 minus h, and now I can plug 0 in for h. Slope of the tan line when x equals, what was it? 1 is negative 2, which means the slope of the normal line when x equals 1, flip it and change the sign. That's right. The point is still the same. It's still 1, what was it? 1, 4? No, 1, 3. Yes. This is the normal line. As opposed to the tan line, which would be the same thing, but with the negative reciprocal slope. Yeah, it's not bad. It's really not bad. If you got tan line, you'll get normal line. You just got to remember to flip it and change the sign. I'm gonna look at it. Yeah, which part? On the difference quotient? Yeah. I don't know. I have to look at it. Did it ask you for the tan line or did it ask you for the normal line?
I'm just saying, like, if it's on the test.
It depends on what it asks. If it just asks you for the normal, then there's no sense in finding the tan. You have to find the tan slope. Oh.
Like, if I find the wrong slope, but I can.
Oh, I see what you're saying.
I know how to find it. I just didn't find it right.
Maybe. Maybe. We'll see. We'll see. All right. Let me show you one more thing and I'll be done. I know. And it's piecewise. So, you need a break? Okay. Square plus 4x minus 1. Is there a place where the tangent would be horizontal, and if so, where? It's going to be at the what? The base of what? The origin? The very bottom of what? You are right, but how am I going to justify? You're saying that because you know that it's a parabola. Okay, let's say that you don't know what the graph looks like. You do, but let's say you didn't, and you need to prove it algebraically. Find where, that's what I wanted you to do. This is a typical question on the AP exam, is where, all right, y'all, listen. You have a homework problem like this. I'm doing one of them with you, and I'm going to give you the other one for tonight. The question is, where is the tangent line horizontal? And Lainey said, of course, it's at the bottom of the graph. Anywhere else, it would intersect more than once, right? And she's right. But algebraically, how am I going to show that? Or calculusy? What is it? Calculus? Not algebraic, but calculus. I don't know. Calculi. Okay. So we could, but let's say we didn't have a calculator. Find where the slope is 0. So remember, to find the slope, I'm doing the limit as h approaches 0 of f of x plus h minus f of x over h. I want to know, where is this going to be 0 for this particular f of x. So I have to plug it in and solve it. So let's think about it. The limit as h goes to 0, x plus h, y'all like to do that off to the side, right? F of x plus h of this function would be x plus h squared plus 4 times x plus h minus 1. It doesn't, that's what I have to find is the point. I've got to find the x that's going to make this work. Well, let's see if we can do it. Let's see what happens. Let's see. This might blow up in my face. Indubitably. I thought it was going to simplify some, but there's no like terms there. Nobody ever knows what Brian's going to say, that's for sure. Yep, so this is f of x plus h. This is f of x. I don't want the x to be 0. I want this to equal 0. Okay, so let's see what happens here, because I'm going to distribute this minus sign, okay? So I got x squared plus 2xh plus h squared plus 4x plus 4h minus 1 minus x squared minus 4x plus 1. All over h, and I need this limit to equal 0. Because that's what the slope of the horizontal line is 0, right? I don't want anybody to miss that point. Okay, so some things start canceling out. We must be doing something right, Stella says. The x squareds are gone. The 4x's are gone. The 1's are gone. Ooh, this might be nice. Okay. The limit as h goes to 0 of 2xh plus h squared plus 4h over h. Oh, they all have an h in them. Okay, so watch what I'm going to do. I'm going to take an h from everybody. 1, 2, 3, 4. Look, this is the exact same thing we've been doing, but we've kept the x in there this time. So it's a longer problem because of all. There's more room to make a little mistake in here and there. But all right, 2x plus h. Where does that agree or disagree? Oh, sorry. Can I evaluate this limit now? Yes, I can plug a 0 in for h now, right? No problem. Do we all agree? I can do that because I'm not dividing by an h anymore. So actually, this limit is going to be 2x plus 4. Agree or disagree? Now I can solve for x as a linear equation. Oh, wasn't that fun? Look what y'all did. What does that tell me? That's exactly right. The slope of the yeah. There was an h in every single one of them. So I just took one of them. Oh, here I plugged 0 in for h. Once I got it to where the h was out of the bottom, I could plug that 0 in and it was no problem. That's exactly right. We're back to that very first part of limit evaluation where we have to do a manipulation to be able to plug in. That's it for that. X is -2. If I'm asked for the specific point, I'd need to go back to the beginning and find f of -2 to find that point, because that point happens at, what was that equation? X squared plus 4x minus 1. That'd be 4 minus 8 minus 1, which is... We have a horizontal tangent at the point -2, -5. And I know that because the slope of the tan line is 0 at that point. Isn't that cool? Okay, y'all, it is cool. I don't care what y'all say, it's cool. It's cool. It's cool. I'm fixing to shut up. Let me just show you real quick about it, and I don't even have to do a lot with it. 1. Don't at least try it. It's very, very similar. It's very, very similar. And it's a quadratic like this one. Okay, piecewise really quickly. Should I show you one that works or doesn't work? I'm going to show you one that doesn't work. This is number 15 on your homework. I've been doing homework problems as the example so that we're working through them as well. Welcome. To keep the leading coefficient positive. Oh, no, I don't know. So it says determine whether the curve has a tangent at the indicated point. If it does, give its slope. If not, explain why. This goes back to our continuity. It goes back to what happens whenever we have like this questionable piece of maybe it's continuous, maybe it's not. And then I'm going to tell you this just to make it easy. I know I'm trying to finish so y'all have time to at least get through a few problems before you leave. So I'm just going to tell you what to do. The slope of the tan line from the left has to equal the slope of the tan line from the right in order for the function itself to have a tan line at that point. It's kind of like the limit from the left had to equal the limit from the right and had to equal the function value in order for it to be continuous. It's the same kind of thing. The slope from the left has to equal the slope from the right. And if that happens, then the slope of the tan line at x equals 0 is that value. So you work out both of them and see if they equal at 0. Then no, it does not have a tan line at that point. The limit is h goes to 0, but you're doing it at 0 for each of them. Now look, if it's a line, y'all, think about this. Yes, it's always as h, because h is the difference between those, the distance between those 2 points, and we want that to be. Now, look, there's not as much work on this as what you're thinking. If I have a line, it's a constant slope, right? No matter where my tan line is on this, the slope is the same, yes? So for this, my slope is 2 always and forever on that line. Okay, this is a line, right? This is a parabola, and this is a line. Yeah, that's what that is. That's exactly what that is. So you're looking, whenever you find the slope of a tan line, you're looking at the slope as you make your way around the curve, right? Well, if I make my way up and down a line, what's true about the slope? It's the same. It's never going to change no matter where I am on there, right? So this has a constant slope of 2. So really what I'm looking for in this problem is at 0, does that have a slope? What's the slope of the tan line when x equals 0? Well, if I don't get 2, then it's a no for this one because they have to be the same. Does that make sense? Okay. All right. You want me to do it real quick? Yes. Matt, what did you say? Bro, where were you on that whole conversation just now? I'm not trying to bring you out. I'm sorry. It's always 2 because it's a line. If you plug an indifference question, you should. Are you doing it at 0? You let your x be 0. The limit is x as h approaches 0. F of x, actually 0 plus h minus f of 0 over h. You did the 2x plus 2. Well, 0 plus h is going to be 2h plus 2. F of 0 is going to be 2. I think it is. What number is that? 15. The top one's -2, the bottom is +2. So it doesn't work. So no, it does not have a tan line there. All right, let me give you what I got for you. Let's do, and we may end up spending, we may push the test to Thursday and spend Monday doing these kind of problems. We'll see how things go. Let's do, I know, let's do 16. Y'all are going to kill me for 18, but I'm doing it anyway. No. Thing's hot. Yeah, I think we'll definitely pick up on Monday because there's a bunch that I still want to do in this section that's really, really good. Those are your multiple choice ones. Those are multiple choice. I saved some of the,